Okay. So this says a small regional carrier accepted 19 reservations for a particular flight with only 18 seats. Big no. 15 reservations went to regular customers who will arrive for the flight. Each of the remaining passengers will arrive for the flight with a 55% chance, independently of each other. What is the probability that the overbooking occurs? So these 15 people are going to show up. So we don't care about them. Of the remaining three seats, there's 3 seats left over. An overbooking occurs if all 4 of the remaining people show up. So we have 4 people, 3 seats. Overbooking occurs if all 4 people show up. So you can think of this as a binomial distribution, 4 independent trials, each trial having a 55% success rate. So I wonder the chances that all 4 things occur. So we're looking for one particular outcome. So this is going to be a binomial PDF. 4 trials, a success rate of 0.55, and I'm looking for the probability of all 4 occurring. So if I do that, so remember, binomial PDF is for one specific outcome. Binomial CDF is for multiple outcomes, less than or equal to a specific number of outcomes. So binomial PDF, we have 4 trials. The success rate of each trial is 0.55. I want to know the chances that all 4 people show up. So the chances of that happening is 0.0915. 0.0915. So it says find the probability that the flight has empty seats. So the probability that it would have empty seats would be the probability that the number of people from this 4 is less than or equal to 2. If 3 people show up, all the seats are taken and there's no empty seats. The only way that there's an empty seat is if 2 or fewer people show up. This is going to be binomial CDF, 4 trials, success rate of 0.55, and we want to know the chances of 2 or fewer. So we go binomial PDF or CDF. Would be 4 trials, success rate of 0.55, less than or equal to 2. So we get 0.6090. 0.6009. Okay. And now this is Air USA has a policy of booking as many as 20 persons on an airplane that can only seat 19. Why do they keep doing this? Past studies have revealed that only 82% of the booked passengers actually arrive for the flight. So the success rate of any person showing up is 82%. Find the probability that if Air USA books 20 persons, not enough seats will be available. So we're looking for the case where all 20 people show up. There's only 19 seats available. The only way that there's not enough seats is if all 20 people show up. So this is binomial PDF for one specific outcome. 20 trials. Success rate of any given trial is 0.82. And we're looking for the chances that all 20 show up. So if I do that, pull up binomial PDF, 20 trials, 0.82, 20 trials. So this is 0.01889 or 0.0189. So it says, is this probability low enough that overbooking is not a real concern? So they say the cutoff is 5% or less. This is less than 2%. This is 1.8%. So yes, it's low enough to not be a concern. What about defining unusual as 10% or less? Well, if it's fair enough for 5%, it should be fair enough for 10%. That's why these are both yes. 5% is really the cutoff. Really, but I think that's not good enough. Honestly, if something happens 4% of the time, you have a lot of angry passengers. But so this is just going to be binomial PDF, 20 trials. Success rate of any given trial is 82%, and there's chances of 20 people showing up.